1985, number 27. So how do you integrate absolute values? What the heck is going on? So what does the absolute value look like? So you need to break this up into a piecewise function. And then it'll all start to make sense. Or we can graph this. If you know what the graph looks like, you're able to do this also. So we'll look at both methods in case it's not a simple graph. If x minus 1 is positive, I don't need the absolute value sign, right? When is x minus 1 positive? X minus 1 is positive if x is greater than or equal to 1. Do you agree? Hopefully. If x is greater than or equal to 1, that will be positive. If it's positive, then I don't need an absolute value sign. So your function f of x will equal x minus 1 as long as the inside's positive. Now, if the inside's negative, so if x is less than 1, this will be negative. How does the absolute value make something negative positive? It takes the opposite of it, opposite of x minus 1. So here's the piecewise function for this function. So it changes at 1. So I would rewrite this integral as the integral from 0 to 1 plus the integral from 1 to 3. So I broke this from 0 to 1 and then 1 to 3. But from 0 to 1, it equals this function because that's the left of 1. So that's actually going to be minus x plus 1 dx. And then from 1 to 3, it's going to equal that function. So I'm going to do x minus 1 dx. And then I do this. It's minus x squared over 2 plus x from 0 to 1. That's going to be x squared over 2 minus x from 1 to 3. And now it's just a lot of algebra. But I'm going to show you actually a faster way of doing this. I'm just showing you a general way. I'm going to plug in the 1 first. So it's going to be negative 1/2 plus 1 minus 0. I'm going to plug in a 3. That'll be 9/2 minus 3 minus, then I'm going to plug in 1, 1/2 minus 1. And then hopefully get the answer. That's going to be 1/2. That's 4.5 minus 3. That's going to be 1.5. And then 1/2 minus 1 is negative 1/2. That's going to be 1/2 plus 3/2 plus 1/2. That's going to be 2 1/2 or 5/2. Bada bing. But I'm going to show you an easier way. An easier way. There's got to be an easier way. Hopefully I can get rid of this without losing my... Okay, that works. Just a few little pieces here. Oh, I knew that was going to happen. Okay. Oh, if I hit the edge of the square that I put on top, I delete the square. Okay, we're good. Here's the other way of doing it. Draw a picture of this. And this is much faster, actually. There is the absolute value of x minus 1. I'm integrating to 3. So basically, I just want the net area. I want the area of those two triangles. Yeah, it's much easier, huh? But if this weren't such a simple graph, say it was x squared minus 1, you'd have to do it this way. So that's why I don't mind showing you the long way. So this will be 1/2 base times height. And the second one is 1/2 base times height. For the net area. That's going to be 1 plus, whoa. Did I mess up here? Did I mess up? Because my answer is not going to match up. Oh, no. This is 1/2. I thought that was 1. 1/2 times 1 times 1 is 1. New math. And that's going to be 2. So 2.5, which is 5/2. Much faster that way, eh? That's it for that one.